Okay, so for example, if you have the system that contains three variables, three unknowns, so three equations, three unknowns, you have x sub 1 minus 2x sub 2 plus 3x sub 3 equals 9. And let's say you have negative x sub 1 plus 3x sub 2 equals negative 4. And then 2x sub 1 minus 5x sub 2 plus 5x sub 3 equals 17. The augmented matrix of the system contains all the numerical coefficients. In the first row, all the numerical coefficients and the right-hand side constant in the first equation. So 1, negative 2, 3, 9. And then in the second row, all the numerical coefficients and the right-hand side constant. In the second equation, negative 1, 3, 0. There is no x sub 3 here. And then negative 4. And then the entries in the third row would contain the numerical coefficients and the right-hand side constant in the third equation. It's 2, negative 5, 5, 70. Okay? In some cases, in some books, they put a vertical line here, bar. Okay, just to say that these numbers on the right-hand side of the bar are the right-hand side constants of the equations. Okay, now we can transform this into its REF, or the row echelon form, or its RREF form, or the reduced row echelon form. Okay, now the method of transforming, a matrix into its REF or row echelon form is called Gaussian elimination. Okay, Gaussian elimination. Now, the method of transforming a matrix into its RREF is called Gauss-Jordan elimination. Gauss-Jordan elimination method. Okay? Now, how would you know if a matrix is in REF and in RREF also? So, in matrix, let me just recall, in REF or row echelon form has the following properties. First, if there are any zero rows, so rows containing all zeros, they must be at the bottom of the matrix. Okay? Any zero row must be at the bottom of the matrix. And then for a non-zero row, its first entry, called the leading entry, must be 1. The first entry of a non-zero row must be 1. This is called the leading entry. So the leading entry of a particular row. And then thirdly, for successive non-zero rows, the leading entry of the higher row must be farther to the left of the leading entry of the lower row. Okay? For successive non-zero rows, the leading entry of the higher row must be farther to the left. Left of the leading entry. Of the lower. Okay? So a matrix in REF has these properties. Now a matrix in RREF, which is also in REF, has the same properties, but there is an additional one. So a matrix in REF is in RREF, or reduced row echelon form, when every column that has a leading entry has zeros in every position above and below, and below its leading entry. Okay, so that's how you can say that a matrix is in RREF. Right. Now, how do we transform? How to transform a matrix into its REF or RREF? The answer is we use elementary row operations. Okay. As you may have remembered, we have three elementary row operations. So three elementary row operations. Okay. I'll give them to you, and then the notations also that we'll be using whenever we perform elementary row operations. Okay, first interchanging two rows. Interchanging, let's say, a particular row I and row J. Our notation would be like this. If you are interchanging row I and row J, you'll be using this notation. Okay. Another elementary row operation that we know of is multiplying a row by a non-zero constant. So row I by a non-zero constant. For example, we are changing row I by by C times row I. So this would be our notation. So if you're changing row 1, then I would be 1. Now row 1 with 2 times row 1. So our notation would be row 1, then this arrow 2 times R1. Okay. And then adding a multiple of one row to another of row I to row J. Okay, say for example, we are changing row J with row J plus a multiple of row I. Okay, it will be our notation. Okay, so to solve a system using Gaussian elimination method, what we'll be doing is to transform the augmented matrix of the system into its REF using elementary row operations. Okay, so that's what we'll do in the example. Okay, solve the system of linear equation above by Gaussian elimination. Gaussian elimination method. Okay. So this is the system above there, and we'll be needing this. It's augmented matrix, and then we need to Okay, we have to transform this into its REF. Okay, using elementary row operations. So let me just write that again. 9, negative 1, 3, 0, negative 4, 2, negative 5, 5, 7, 2. Okay. The first thing that you have to do when you want to transform your matrix into its REF is to have a leading entry in the first row, which we already have there. Okay. So if it happens to be another number other than 1, no? Let's say, for example, this is 10. Then you have to make this a 1 first to have so that the first row will have a leading entry. And then after that, you have to make all the entries below that leading entry zeros. So we'll have to change this to 0 and this also. Okay? So let's copy the first row because we won't be changing anything in that row anymore. And then change R2 using an elementary row operation. Okay. Change R2. We are changing R2. We can just add R1 and R2, right? So, unahin ko muna si R2, whatever row that we are changing, and then add to R1. Okay? We are actually using this elementary row operation, the third one, adding a multiple of row I to row j. But then C here, which is the constant, is just positive 1. No? Okay. So adding the 2, you'll have 0 here. 3 plus negative 2 is 1. 0 plus 3 is 3. Negative 4 plus 9 is 5. Okay, and then we need to change R3 also. R3. Okay, use an elementary row operation to make this 0. So we are changing R3. Okay, plus a multiple of row 1. We use row 1 always because row 1 has the leading entry already. So always use the row with the leading entry to change this to 0. Okay, so if you multiply row 1 by negative 2, this becomes negative 2, and then you add here, you get a 0 in this. Okay, so multiply by negative 2, that particular row 1. So if that happens, you get 0 here, 0, and then you have, for this particular entry, you have negative 5 minus 2 times negative 2. It's negative 2. So you get negative 5 plus 4, it's negative 1. Okay, now here for this particular entry, 5 minus 2 times 3, you get 5 minus 6, negative 1 also. And then you have for 17, minus 2 times 9. So that's 17 minus 18, you get negative 1 again. Okay. Now, we have leading entry in the first row and then zeros below it. We have to have a leading entry in the next row, which we already have here. We already have a 1. So if it happens that this is not 1, you have to make this a 1 using the second elementary row operation. Okay? You have to multiply this number by its reciprocal. Okay? Now, since we already have a leading entry in the second row, what we have to do is make all the entries below it 0. In this case, we only have one entry. We make a 0, so it's we will not be changing anything with the first and second row. 3, 9. So this will be 0, 1, 3, 5. Right? So we'll change R3. R3. Okay. We use R3 here and then R2 because R2 has a leading entry in the second column. Now, adding R3 and R2, we get 0 for that particular entry, right? So now we have 0. Adding this 2, we get 0. Adding 3 and negative 1, we get 2. Adding 5 and negative 1, we have 4. And then finally, we have to have a leading entry in the third row. Leading entry in the second row, leading entry. And we can have that by multiplying row 3 by 1/2, right? So for row 3, we are changing row 3, multiply row 3 by 1/2, row 3, 1/2 R3. So that this becomes 1, right? So we now have 1, negative 2, 3, 9. And then 0, 1, 3, 5. And then multiplying row 3 by 1/2, we'll have 0, 0, 1, 2. Okay? Take note that from the start, this is the column of x sub 1, this is the column of x sub 2, x sub 3, and these are the constants, right? So it's the same thing um, in our last matrix. So now, by backward substitution, Gaussian elimination always involves backward substitution. In backward substitution, you have to write your matrix, okay, the system of linear equations in matrix form. You have to transform it again in equation form, okay? Now, writing the first line, the first row as an equation, that's this is the column of x sub 1, x sub 1, x sub 2, x sub 3. These are the right-hand side constants. So you have 1 x sub 1 minus 2 x sub 2 plus 3x sub 3 equals the constant 9. And then for the second row, you have 2x sub 2 plus 3x sub 3 equals 5. And then for the last row, you have x sub 3 equals 2. So from the last row, you get the value of x sub 3, which is 2. And then by backward substitution, you have to substitute the value of x sub 3. So in equation 2. So let's call this equation 1, and this is equation 2. So substitute x sub 3 equals 2 into equation 2. So that's 2 x sub 2 plus 3x sub 3, where x sub 3 is 2, equals 5. So that's 2x sub 2 equals 5 minus 6, or 2, mali ba ako? 2x sub 2. May mali ako pinopya niya. 1 lang pala. Yan, 1, 1, 1. X sub 2 lang. This is 1x sub 2 lang. Okay, x sub 2. Yan. Is 5 minus 6, or x sub 2 is equal to negative 1. Okay, now substitute x sub 2 equals negative 1 and x sub 3 equals 2 into equation 1. Equation 1 is there. So we have x sub 1 minus 2 times x sub 2 plus 3 times x sub 3 equals 9. Solve for x sub 1 from there. So this is x sub 1 plus 2 plus 6 equals 9. Or x sub 1 equals 9 minus 8. X sub 1 equals 1. Okay? Now to write the solution in matrix form, our three unknowns are x sub 1, x sub 2, and x sub 3. And these are the values. 1, negative 1, 2. And that's the solution to the system of linear equations using Gaussian elimination method. Okay? Do you have any questions? 1 plus po yung R. Oo. Kasi ano yun eh. That's actually, itong part na to, no? That is actually R3. So R3 plus negative 2R1, you know? Negative 2R1. So it's R3 minus 2R1. Diba? So parehas lang. R3 plus negative 2R1 is just R3 minus 2R1. Okay. Any other questions? Okay. Good. So let's go to the Gaussian elimination method. So it's the same thing, but instead of transforming the augmented matrix into its REF, we'll have to transform it into its RREF, but it will not be involving the backward substitution anymore. So right away from the RREF form of the matrix, you'll be able to get your answer. Okay. So the given system of linear equations using Gauss-Jordan elimination. Have x sub 1 minus 3x sub 3 equals negative 2. And 3x sub 1 plus x sub 2 minus 2 x sub 3 equals 5. And then 2x sub 1 plus 2x sub 2 plus x sub 3 equals 4. Right. So let's obtain the augmented matrix of the system. So a column of row of x sub 1, 1, tapos we don't have an x sub 2 here, so the next entry is 0. And then for the column of x sub 3, the coefficient of x sub 3 in the first equation is negative 3. And then the constant is negative 2. Okay, for the next equation, we have 3, 1, negative 2, 5. And then for the last equation, we have 2, 2, 1, 4. Okay, again, the first step is to have a leading entry in the first row, but we already have that. So we just have to make these two entries equal to 0. So for row 2 and row 3 only. So row 1 will remain the same, 1, 0, negative 3, negative 2. Okay. So making this a 0, so we'll change row 2. Now row 2. So that's row 2. If we multiply row 1, we'll use row 1 because it has a leading entry already. If we multiply row 1 by negative 3 and then you add them, you get a 0 here for this particular entry, no? So minus 3 R1. Minus 3 R1. So this will be 0. Okay, so R2 minus 3 R1 would still be 1, no? R2 is 1. Now we have here negative 2 minus 3 times negative 3. Negative 2 minus 3 times negative 3 is 2 plus 9, no? So we get negative 2 pala, negative 2 plus 9, so we get a 7. And then for this particular entry, that's 5 minus 3 times negative 2. So it's 5 plus 6. That's 11. Okay. And then for this particular entry, for this 2, no, you enter in the first, in the third row, first column. So that's in row 3. We have to change the entries in row 3 by the operation R3. minus 2R1. Okay, because if we multiply R1 by negative 2 and then you add them together, then 2 minus 2 is 0. So this becomes 0. Okay, since that is 0, so this will remain to be 2. And then we have 1 minus 2 times R1. R1 is negative 3, so that's 1 plus 6 now, no? We get 7. And then 4. 4 minus 2 times negative 2. We get 4 plus 4. That's 8. Okay. And the next is to have a leading entry in the second row. We already have a leading entry in the second row. So what we have to do is, so in this column, we already have a leading entry, no? So all the other entries in that column must be 0. So since this entry above the leading entry in the second column is already 0, so we won't have to do anything about that anymore. So we'll just have to make this entry below the leading entry in the second column is 0. So gagawin natin 0 yung 2 na yun. Okay. So we'll not be changing anything with the first row. Negative 3, negative 2, 0, 1, 7, 11. Kaya tingnan ko may mga mali ako sa pag-add. Okay. So we'll change R3. And this time we'll be using R2 to make this a 0 because R2 has a leading entry. So that's R3. If we multiply R2 by negative 2, and then you add them together, you get 0 in this particular entry. So minus 2R2. So this will not change. This is still a 0. Now this becomes a 0. And then R3, so 7 minus 2 times 7. That's 7 minus 14, so it becomes negative 7. And then R3 is 8 here, minus 2 times 11. So that's 8 minus 22. Then 14, negative 14. All right, so the final step, not yet. We have to have a leading entry in the last row. So this should be a positive 1, no leading entry. Ako na lang ilalagay sa baba. So we will not be changing anything with the first two rows. 0, 1, 7, 11. We have to make this a 1, so we have to change R3 again. This should be 1, so we multiply R3 by negative 1 over 7. It's reciprocal. No? So multiplying by negative 1 over 7, we get 0, 0, 1, and then this becomes 2. Negative 14 divided by negative 7 is positive 2. And then we have, since the third column already has a leading entry, we have to make these two numbers both equal to 0. Okay, these two entries above the leading entry in the third column. So that could be the last two steps. Okay, we have to change R2. R1 muna. R1. We'll be using R3 because R3 has a leading entry in the third column. Okay, R1. This is negative 3. So if we multiply R3 by 3 and then you add them together, you get 0 here. So plus 3R3. So this is 1, 0. This becomes a 0. And then multiply this by 3. we have R1 is negative 2 plus 3 times 11. So negative 2 plus 33. Ayan. We get 31. Parang may maling number. Wala ba akong, kindly check nga kung meron akong maling mga addition. Ay, hindi pala 11 kasi. R2 pala yun. R1 is... Saan na ba ako? Mali yung number eh. R1 is negative 2. R3 pala yun. Negative 2 plus 3 times R3 pala. 3 times R3. Negative 2 plus 6. 4. Baka ako sobrang laki. Okay. Now, we'll change this to 0. So, this will remain to be 0, 0, 1, 2. No? We are done with the third row. So, for R2, you have to use R3 also. Now, if you multiply R3 by negative 7, and then you add them together, you get a 0 here. For negative 7, no? So, it's R2 minus 7 R3. So, this is still 0. This is still 1. Now, this becomes 0. Okay? And then, for that particular entry, yung 11, ano magiging value niya? So, R2 is 11 minus 7 times R3. 7 times 2. So, that's 11 minus 14. Ano? So, negative 3. Okay, take note that this is the column for x sub 1, x sub 2. This is the column for x sub 3 and the constant. So, no need for backward substitution. No? The value of x sub 1, x sub 2, and x sub 3 are 4, negative 3, and 2, respectively. Okay, this is the solution to the system. Check na natin kung tama. Baka mamaya may mali akong mga numbers. This must satisfy all three equations above. So, checking x sub 1, yung first equation, x sub 1 minus 3x sub 3. So, x sub 1, 4 minus 3x sub 3, 2. This is equal to 4 minus 6, negative 2, no? So, check yung first equation. Second equation, 3 times x sub 1 plus x sub 2 minus 2 times x sub 3. This is 12 minus 6 minus 4. Minus 6 minus 3 minus 4. Minus 3 minus 4. So, this is 12 minus 7. You get 5. Okay, check din yung second equation. And then the third one, 2x sub 1. 2 times 4 plus 2 times x sub 2 plus x sub 3. This is equal to 8 minus 6 plus 2. This is equal to 4. So, check that. Okay, so we get the correct solution. We got the correct solution. Okay, so that is Gauss-Jordan elimination method. Dapat 4 po sagot. Negative 3. Ano ba? Ano yun? Saan yun? Yung kanina pa yun na mistake? Yung kanina pa mistake yun or you are pertaining to something? Okay. Yung kanina pa yun na mistake ko. Alright. Any questions? If not, we'll go to LU factorization. Okay, this is another direct method, ano? Direct method for solving a system of linear equations. Kasi next meeting, I will discuss iterative methods for solving systems of linear equations. Kasi there are cases wherein the solution to the system doesn't contain rational numbers anymore. Kasi pag fraction, rational numbers o kaya whole numbers, no? Ang solution, okay lang si Gaussian elimination, Gauss-Jordan, and LU factorization. But if the solutions are not rational numbers anymore, then we cannot make use of this direct method. So we need an iterative method to solve a system. Okay, and we will be dealing with that next meeting. Okay, so for LU factorization, recall that if the n by n matrix can be written as a product of a lower triangular matrix L and an upper triangular matrix U. Okay, then we say that A equals LU is an LU factorization. Factorization of A. Note that the LU factorization is not unique. Okay, so you can have more than one LU factorization. So example, so if you have a matrix A, a 2 by 2 matrix A with entries 1, 2, 1, 0, if you can factorize it with a lower and upper triangular matrix with entries 1, 0, 1, 1. This is a lower triangular matrix U. And then with entries 1, 2, 0, negative 2, this is an upper triangular matrix, lower, upper, lower, upper. So this is the LU factorization of A. Okay, now you have to learn how to get L and U in this lesson. Okay, do you remember what an elementary matrix is? So an n by n elementary matrix. Elementary matrix. An n by n matrix is called elementary. It's called elementary matrix. Okay, when it can be obtained, from an identity matrix of the same size. Okay, from the identity matrix of the same size, so I sub n, by a single elementary row operation. Okay, let's say for example, if you have a 2 by 2 identity matrix that contains the entries 1, 0, 0, 1. Okay, if you perform one elementary row operation there, let's say for example, you transform R1 and you multiply R1 by 2. Okay, and you obtain 2, 0, 0, 1. This is an elementary matrix. Okay, so now how do you solve a system of linear equations using LU factorization. Solving a system of linear equation by LU factorization. Okay, this will involve elementary matrices. Okay, first you let y be equal to ux. Okay, from there, you have to find the upper triangular matrix U. Second, solve Ly equals B for y. Okay, and then from there, you find the lower triangular matrix L. And then if you have U and L already, then you have to solve the equation that you have created here. So ux equals y, you solve for x. Okay, note that x here is, this is the matrix of the unknowns. Okay, and then B here is, yung B is constant matrix, the right hand side constant. Okay. Now let's solve a system using LU factorization. Solve the given system using LU factorization. Okay. The given system is 2x1 plus x sub 2 equals 1. And then x sub 2 minus x sub 3 equals 2. And then negative 2x sub 1 plus x sub 2 plus x sub 3 equals negative 2. Okay. Step 1 is to let y equals ux. So step 1. Let y be equal to ux. Okay, and then we have to find u. You have to find an upper triangular matrix from the coefficient matrix of the system. Let's write coefficient matrix of the system. This time we won't be needing the augmented matrix, just the coefficient matrix. So these are the coefficients of the unknowns. So 2, 1, 0 for the first equation, 0, 1, negative 1 for the second equation, and then negative 2, 1, 1 for the third equation. The upper triangular matrix, if you still remember, so a matrix is called is an upper triangular one if all the entries below the main diagonal are zeros. Okay, so this is the main diagonal of your matrix. This is the main diagonal. If all the other entries here below it are zero, so you have to make this zeros, then you'll have an upper triangular matrix. So that's what we are going to do. Okay, not necessarily 1 yung mga nasa main diagonal. So okay lang na hindi 1 yung mga nasa main diagonal as long as you make all these entries zeros using elementary row operations. Okay, so I will not be changing anything with the first row. And this is already 0, so there's no problem with that anymore. 0, 1, negative 1. So we have to make this negative to a 0 and also this one. Okay, using elementary row operations. Okay, so we'll be changing R3. Notice that if we add the two together, so R3 plus R1, we'll have a 0 here. Okay? So, sulat ko na lang ng naka-violet. So, magiging 0 na to upon using this elementary row operation. And then adding R3 and R1, we get 2 here. Adding 0 and 1, we get 1. Okay? Now, we have to make this a 1. Ay 0, I mean. Gawin natin 0. Using another elementary row operation. So we'll not change anything with the first row and with the second row. right, so we'll have to make this a 0 using, we can use the second row, no, to make this a 0. So we are changing R3. So that's R3 minus 2, R2. If we multiply R2 by -2 and add them together, we get a 0 here. So this is still a 0, this becomes a 0, and then R3 plus 2, no? So 1 plus 2, we get a 3 here. Okay, now we have an upper triangular matrix. This is our U. We already found it. Okay? Now we have to solve for, in step 2, we have to solve Ly equals B. Okay, and then we have to find L also here. Okay, before we have to solve for Ly equals B, we have to find L. Kasi we'll be solving for Y. Okay, because we already know what B is, these are the right-hand side constants. But we have to find L. Find L. Okay. You have to obtain elementary matrices. Matrices corresponding to the matrices in step 1. Okay. Now, for each elementary row operation performed in step 1, there is a corresponding elementary matrix. Okay. Since the coefficient matrix is 3 by 3 matrix, then we'll start with the 3 by 3 identity matrix also here. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then we can obtain one elementary matrix 1, by performing the same elementary row operation that we performed in step 1. R3 plus R1. Okay, take note that only one number will change here. Only one entry will change from from the identity matrix. Okay, so only one number or only one entry in the third row because we are changing the third row. So first and second rows will remain. Now adding R1 and R2, R1 and R3, sorry, R1 and R3. So R1 and R3. So 1 plus 0, this becomes 1. This is still 0, 0 plus 0. 0 plus 1 is 1. So only one change, this entry, right? Okay, this is an elementary matrix. Now, there is another elementary matrix corresponding to the second elementary row operation that we performed above. We can obtain another elementary matrix E2 by performing the same elementary row operation on R3. So R3 minus 2R2. Okay, again, R3 will change. R1 and R2 will be the same. So 1, 0, 0, 0, 1, 0. And then R3 minus 2R2 will we get? This is still 0. R3, from here, from here. R3 minus 2R2, 0 pa din. So R3 minus 2R2, we get negative 2. And then R3 minus 0, we get 0. So we get 1. R3 minus 0. Okay, so only one entry change. We only use 2 elementary row operations to obtain U, no? So we only have 2 corresponding elementary matrices. Okay? Now, each of these elementary matrix has their inverses. So the inverse of elementary matrix 1 and the inverse of elementary matrix 2. We don't need to perform the long method anymore. We don't need to use the long method to obtain the inverses of these matrices. Okay? Since we performed addition here, no? Addition din to, kaya lang the constant beside R2 is a negative number, no? We performed addition here, so we'll just be needing the additive inverses of the numbers that change here. From from the elementary matrix, we only have one entry that changed. Diba? Itong entry na to. So just get the additive inverse of that. The additive inverse of 1 is negative 1. So that you'll have the entries 1, 0, 0, 0, 1, 0, and negative 1, 0, 1. This is the inverse of elementary matrix 1. And then also performed addition in the second of elementary row operation. So just get the additive inverse of negative 2, and the additive inverse is positive 2. No? So the entries of the inverse of E2 is 1, 0, 0, 0, 1, 0, and then 0, 2, 1. Okay? Now, you have to multiply the product of those inverses. So inverse of elementary matrix 1 times the inverse of elementary matrix 2 is equal to a lower triangular matrix. Now, without performing the multiplication anymore of matrices, what you have to do is copy all the common entries in E1 inverse and E2 inverse, and all the entries that changed also. Okay? So it's 1, 0, 0 common, yung rows 1 and 2. 0, and then this changed. So copy that. And then this changed also, copy. And then this is common to both of them. And as you can see, this is a lower triangular matrix because all the entries above the main diagonal are zeros. Okay, now we find L. Our goal is to solve for Ly equals B. If X is the matrix of the unknowns, X sub 1, X sub 2, X sub 3, then Y would contain Y sub 1, Y sub 2, Y sub 3. Okay? So L, Y equals B. We are solving for Y. So ang L natin is the matrix with entries 1, 0, 0, 0, 1, 0, negative 1, 2, 1. And then Y would be the matrix of Y sub 1, Y sub 2, Y sub 3. And then B would be the matrix of the right-hand side constants that contains 1, 2, negative 2. 1, 2, negative 2. Okay, and then multiply the matrix on the left side. So multiply the first row by this column matrix. Okay, so in equation form, you'll have Y sub 1 equals 1. So this is the column, multiply Y sub 1 and Y1, diba? Yun ang matrix multiplication, row by column. So equals this number. And then the second row, so 0, 0 yung first and last rows, no? Only the second, first and last columns, only the second column has the entry 1. So Y sub 2 is equal to this number here, 2. And then for the third equation, that's negative Y sub 1 plus 2Y sub 2 plus Y sub 3 equals this constant negative 2. So we can solve for Y sub 3 now because we already know the values of Y sub 1 and Y sub 2. So substitute negative 1 plus 2 times 2 plus Y sub 3 equals negative 2. So Y sub 3 is negative 2. Ito ay 3 na lang, ano? Minus 3 equals negative 5. Okay? So we now have yung Y natin, Y sub 1, Y sub 2, Y sub 3 equals, so Y sub 1 is 1, Y sub 2 is 2, Y sub 3 is negative 5. Yeah. And then finally, the last step is step 3. Solve Ux equals Y for X. X is the matrix for the unknowns, no? Ang U natin is this. So 2, 1, 0, 0, 1, negative 1, 0, 0, 0. X 2, 1, 0, 0, 1, negative 1, 0, 0, 3. That's our upper triangular matrix. And then the matrix of the unknowns, X sub 1, X sub 2, X sub 3 equals Y. Y is this, diba? 1, 2, negative 5. And then write this, okay, this equation in equation forms. In equation form, then we'll have, this is the, we have to multiply the rows of this matrix by this column matrix. So you'll have 2x sub 1 plus x sub 2 equals this constant on the right hand side. And then for the second row, you have x sub 2 minus x sub 3 equals 2. And then for the last one, you have 3x sub 3 equals negative 5. And from here, you get x sub 3 equals negative 5 thirds. Okay. Substitute x sub 3 in the second equation. We call this equation 2. So substitute x sub 3 equals negative 5 thirds into equation 2. So that's x sub 2 minus negative 5 thirds equals 2. Or that's x sub 2 equals 2 minus 5 thirds. What do you get? X sub 2 is 1 thirds, right? So x sub 2 is equal to 1 thirds. X sub 2, not x sub 3. And then this is equation 1. We have to substitute x sub 2 equals 1 thirds into equation 1. So that's 2x sub 1 plus x sub 2 equals 2. Okay, so it's 2x sub 1 equals 2 minus 1 thirds. And that is, ano ba ako? 2x sub 1 equals 6 minus, bakit yun? Five thirds. Teka lang parang may mali ako sa ano. Sa equation 1. Tama ba yung kopya ko ng upper? Two x sub 1 plus x sub 2 equals siya. Ay, ito. Mali yung kopya ko. 1, 2, negative 5, 1, 2, negative 5. Equation na lang. So, 1 dapat ito. 1 minus 1 thirds. Ayan. So, this should be 2 thirds. So, x sub 1 equals 1 thirds. 1 thirds also. Ayan. So, ang solution natin, so we have x sub 1, x sub 2, x sub 3. Equals 1 thirds, 1 thirds, and negative 5 thirds. Okay, mali lang yung kopya ko kanina dito. It should be 1 here. Okay. So that's it for LU factorization. Any questions? Okay. Thank you for the correction. Any questions? Okay. So as I've said last time naman, ano lang, maiksi lang yung lecture natin because you're already familiar with the topics. For ano na lang, yung MATLAB, i-ano ko na to. Publish ko na to. Lalagyan ko na lang ng due date mamaya. Okay. So again, what you'll do is copy this in the script window. Gaussian elimination, Gauss elimination method. After this, and then you save, no? Bahala na kayo sa save nyo. Ako nilagay ko lang ng Gauss.m, no? Gauss lang yung ano. Tapos, so ayan, i-paste nyo lang dito, tapos save kung anong gusto nyong function, anong gusto nyong file name. Kung Gauss, akin Gauss. So, pag tinype mo yung Gauss dito, kasi ginawa kong file name Gauss, ano? Pag tinype mo yung Gauss, check permission, bakit nawala? Teka lang ha. Magana na to kanina eh. Bakit nasira? Nasira talaga. Ayun. Okay. Nabura lang siguro. Okay, pag in-enter mo yung Gauss, o kaya ni-run mo, no, ni-run mo yung program na yan, you have to enter the augmented matrix of the system. Let's say, for example, augmented matrix dito, katulad nito. Saan na ba yun? Ito. Ang haba. Augmented matrix na. Augmented matrix na. 3 by 3. Yun na lang, kanina. Yung sinolve natin last time. Yung dito, yung ginamit na lang natin dito. Sa LU factorization. So, itong given na to, ha. Yung given na yan, i-enter ko. Augmented matrix enclosed dapat sa, di ba, set of brackets. Tapos, we have 3 unknowns, 3 equations, 3 unknowns. So, copyhin ko lang na 2, 1, 0. Just to remind you, para mag-separate ka ng entries sa mga columns, no, dapat space o kaya comma. Tapos, mag-separate ng rows, use semicolon, di ba? 210 mali. 2101, tama pala. Second row, 0, 1, negative 1, and then 2. Third row, negative 2, 1, 1, negative 2. Ayan. So, lumabas yung mga sagot. Yung kanina 1/3, 1/3, 1/3. X sub 1 is 1/3, X sub 2 is 1/3, and then X sub 3 is negative 5/3. So, ganyan lang lalabas niya. In-enter ko lang yung augmented matrix ng system. So, ganun lang. In your activity, so magiging paulit-ulit lang siya, no? Kaya lang ito, medyo malaki-laki yung mga matrices mo sa practice. And then, you have to answer some questions here. And then, you repeat the same procedure for all of these matrices. Okay? Using the same function that you have created. Okay. So, lalagyan natin ng Sa Saturday is your quiz, no? You start at 1:30. So, that is quiz 3.1. Tapos, I'll give you a homework which is to be submitted on Saturday also. So, hanggang 11:59 PM naman yun sa Saturday yung homework. Gawin na lang natin submission ng activity nyo is Tuesday, 11:59 PM din. So ito, pag pinalalagyan ko na ng ano, makalimutan ko pa. Tuesday, 11:59 PM. So it's available now hanggang sa Tuesday. Okay? Okay, so ang next conference natin, na-mention ko na ba kanina? Next conference natin, Tuesday ha. Tuesday tayo, not Thursday next week. Kasi Thursday next week, midterm exam na agad eh. Yun ang masyadong tight yung nilagay nilang schedule. So, sundin na lang natin yon. Thursday, midterm exam. Tuesday, conference tayo ulit. And submission din nung ano nyo, nung activity number 3. Ha? So, Tuesday, next conference, same time. Questions? Hindi na po 1 week simula. Kasi, hindi na. Mabilis lang naman yung simulation eh. Saglit lang yun. Matatagal lang kayo sa pag-enter ng matrix. At saka ginagawa nyo naman kung kailan due date na, tsaka kayo magsasubmit eh. So kahit gaano katagal lang ibigay ko sa inyo, gagawin nyo siya during the due date. Di ba? Medyo tight ang schedule natin eh. Every Tuesday, akala mo every Tuesday quiz. Hindi, sabi ko sa inyo, di ba, pwedeng magpalit yung schedule ng conference natin. Na pag hindi tayo nag-lecture ng Tuesday, hindi tayo makakatapos ng lessons. Assignment, Saturday. Due date Saturday at 11:59 PM. Ang quiz nyo Saturday din. Ha? Magme-message ako mamaya. Mag-inbox ako sa inyo mamaya after our class. Simulation pa lang na-post. Oo. Gagawin ko pa lang, ipa-publish ko pa lang yung assignment at saka yung quiz. Ha? Ay. May questions pa kayo? Attendance. Here. I will send the attendance also later through announcements. Yung booster mo sa Saturday. O, edi, pakita mo na lang yung mo sa akin. Yung vax card mo. Yung vax card na nag-booster shot ka ng Saturday, schedule ng quiz natin. So, i-open ko na lang ulit para sa'yo yung yung quiz. Okay? Yung assignment, gawin mo na lang bukas. O kaya mamayang gabi. Diba? Para hindi na siya maapektuhan. Kasi merong necessary yung merong corresponding deduction sa assignment eh. Unlike sa quiz. Sa assignment, pag late submission, may deduction. Okay, just in case lang, bigyan mo na lang ako ng proof niya, box card, ha? May questions pa yung iba? Sa quiz po about sa topics despite po na may given intervals, need pa po i-check kung ano mas malapit na roots. Ano yung sabihin need pa po i-check kung ano mas malapit na roots? Hindi siya pumasok dyan? Ibig mo sabihin yung nakuha mong solution, hindi pumasok dyan? Hindi pumasok sa interval? Mas malapit po is -2, -1. Oo. Kasi kung ano yung interval na binigay, dapat yun ang kasi otherwise mag-iiba yung values mo eh. Pag iba ang intervals mo, di ba multiple choice type yun? So, dapat parehas tayo ng solution. So, dapat parehas tayo ng solution para yung sagot natin maging magkapareho. Kasi kung magkaiba tayo ng interval, yung magiging approximate values mo would be different. No? So, kaya given talaga yung mga initial approximates doon. Sa quiz po kami po magta-type. Multiple choice yung quiz ngayon. Pwede po makita yung, I still have to check kung meron pang hindi nakakapag-quiz. Madami kasi nagme-message ng special quiz. May mga excuse letters naman sila. So, I still have to check. Yes, may choices din yung midterm exam. Oo, mag-message ako later. To inbox, dito sa Canvas. Yes, multiple choice nga yung quiz 3. Tingnan natin kung multiple choice lahat. Basta multiple choice. Yeah, multiple choice. Meron lang yata, I'm not sure kung sa assignment yun or sa quiz. Yung nilagay ko, meron lang, may ibang numbers na mag-enter ka ng values. Pero fractions naman tayo dito, di ba? Wala naman tayong mga decimal numbers pang i-discuss. Baka po kasi matapat yung gusto follow through. Basta pag merong excuse letter o kaya merong basta meron kayo evidence na na may ginawa kayong importante during the quiz, bibigyan ko naman kayo ng special quiz. Walang problema. Okay? Ano pa? Wala na? End ko na tong recording.